Alrighty, back to the grind. All warmed up or all tired up? Well, let's see what we got. Longest binary subsequence less than or equal to k. You're given binary string s and positive integer k. Return the longest subsequence of s that makes a binary number less than or equal to k. Subsequence can have leading zeros. The empty string is considered to equal to 0. The length of the longest subsequence. So length of 0, length of the empty string is 0. A subsequence is a string that's derived from another string by deleting some or 0 characters without changing the order. The length of the longest subsequence of s that makes this binary number less than or equal to k. Interesting. So here the binary numbers, or the number is 5. And binary 5 would be 101 for 1402's 11. So you can definitely delete these things to get 101. Oh, hon. So you're trying to find the longest subsequence. Longest subsequence that makes a binary number less than or equal to k. Interesting. So you could. So you could keep. You want to have the leading zeros, because that makes it longer. So you don't want to keep this one because that prevents you to have leading zeros. So you delete that one. You have 0, 0. Technically, you could have 0, 0, 0, 0, 4 zeros, which is a number smaller than 5. But then you could also have. You can also keep an extra 1. So like 0, 0, 0, 1, 0. That'd be 2, which is less than 5. That'd be 5 long. You can't keep 6, because that means that you'd be keeping 2 ones, unless the ones were like the ones place in the seconds place, or the ones place in the fourths place. You can't really, you're not going to be able to keep the last 0, because that last 0 prevents it being a small enough 1. So if you kept all 6, then this is the 2's place, this 8's place, and this is like 10. So you could maybe get 5 exactly. You get, if you kept 1, 0, 0, you can get 4. Or you get 0, 0, 0, 1, 0, you can get 2. So anyways, this is 5. So here this is smaller than or equal to 6, or smaller than or equal to 1. So here I guess you want to keep the last 1 and all the zeros before it. So 0, 0, 0, 0, 0, 1. So that'd be 6 numbers. Interesting. Huh. So how to go about this? I think you want to go backwards, forwards, I guess. I'll go backwards, forwards. Here, go backwards. Okay, so let's double check here. The length is 1,000. K could be any number from 1 to 10 to the 9th. So that's a pretty big number. Interesting. So, I mean, you could have a bunch of leading zeros. And you probably want to get as many leading zeros as possible. So what's the downfall of trying to be greedy and get all the zeros to be leading? At that point, you're not really getting the ones that you could possibly get. Like here, get all the zeros to be leading, then you get this last zero to be leading, and you get 4 zeros exactly. But you could have inserted one at some point. So trying to figure out whether or not I should be trying to think about this going from right to left or left to right. If I go left to right, then, and I'm maybe you start with all your zeros. You start with all your zeros, and then you try to add back in your ones and see what ones you can add back in. So if I start with all my zeros here, if I start with all my zeros here, then I have 4 zeros. And then why would I ever want to put this one back in if you replace this 0? I guess you'd never do that, right? You just this 0 versus this 1. You do that because this 1 would be now a 2. And if your number is bigger than 2, then you're basically inserting a 2. You're increasing the value of the number by 2. I guess the downside to that might be that by inserting this 2, you're kind of locking into this one as a 2, and also anything further up the line as being something that's bigger than place value of 2. Is that correct? I think so. Okay. That's kind of greedy approach. I don't think that greedy approach works. I can imagine when there might be cases where you don't want to do that. So like, let's say it was, I don't know, 0, 0, 1, 1, 1, and then 0, 1, 0. And let's say why would you want this? So let's say k is actually let's have a bunch of zeros here. Let's say k is 1, 2, 4, 7. So I feel like here you want to have this as your best substring. And if you're locking in this as 2, then I think that might prevent it. I guess if you lock this in as the 1's place, then it's still fine. If you lock in this as a 2's place, then you can't necessarily have all the 1's here. I guess you're replacing this 0, 1 with these two ones. Say a bunch of zeros. 1, 1, 1, 0, 1, 0, 1. It's probably going to give an error. So the best thing here was 10. So how many zeros I have? 5 zeros here. And then 2 and 3 here. But it could also have been 5 zeros, 2 zeros, and then the ending 0, 1, 0. So these ones could have been replaced with this 0, 1, 0. And what to do there? Could I piece it together going backwards? So I have a 0, I have a 1. That means I could maybe have 2 characters that have a value of 2, or 1 character that has the value of 1, or 1. If I just use a 0, then it means I have 1 character with the value of 0, or 2 characters with the value of 2. And then here I have 3 characters with the value of 2, or 2 characters with the value of 0. If I do 0, 0, or 1 character with the value of 0. And then if I extend this out here, 4 characters with the value of 2 plus 8 is 10. So 4 characters value 10, or I guess my best 3 would be 0, 1, 0. So for each, if I iterate over the characters backwards, I can determine the best. Or by best is the smallest value formed of something of each possible length. Something of each possible length. The smallest value. So length 4 would be 10, length 3 would be 2, length 1 would be, length 3 would be 2, length 2 would be 0, and length 1 would be 0. Should I be doing this going left to right or right to left? Maybe I should be doing this left to right. So here, 1 thing that's 0, 2 thing that's 0, 3 things that's 0, 4, 5, 6, 7 zeros. And then here it'd be 8 things. 1, 2, 3, 4, 5, 6, 7, 8 things with value 1. 9 things with value 1 plus 2 is 3. Is the 8th thing still value 1? Yeah. 10 things with value 7, or 9 things with still value 1, or value 3. Here, I could, add a 0. So this 0 could append to something of size. I wonder how fast that is. That seems to be for each length in the thing. I'm going through each possible thing, so it's like maybe dynamic programming n squared. I mean, 1000 is short enough to do n squared, I think. Okay, so I think going left to right seems slightly better. Alright, let's see dynamic programming. So this is going to be a 2D array where the rows is the length and or the rows, the outer is going to be the index within the string, and the inner is the least value that you can get with that number of characters so far. Dynamic programming, 2D array, outer index, the row index is index in for string s, and the column index is the minimum value using that number column characters. Okay, so I think this should probably be, I'm going to start with 0 times, well, let's say n is the length of the string. I'm going to say n plus 1 generally is how I set this up, and then this is going to be a single number. Actually, should it just be, I could probably just make this a 1D array and keep the best thing for that iteration. Yeah, so the best index. Sure. Index is the min value characters using, so I'm going to say this is tracks min value using x, or x is the index, chars in string. Okay, so it should probably just start with the min value should be infinity times n plus 1, and technically the first one, if you use 0, then you get 0. Yeah. Okay. So for every value, for every bit in string s, I'll just say the value is 1 if bit equals 1, else it's 0. And kind of want to go in reverse order here. Otherwise, it's going to have some side effects. I'll deal with side effects first and then I'll fix it. So in general, what I would want is the relation between the let's see, if the next bit is 0. So let me consider how I process this. So given the 1, 1, 0, okay, so dp is initially 0, which is to say that if I have 0 characters in the array, I have a 0. What does that mean? If I have 0 characters in the array, the minimum value that I get with my string is going to be 0. Okay, and then I look at the first character is 1. Then I can say I can make a string of 0 characters with value 0, or I can make a string of 1 character whose minimum value is 1. Next time I do a loop, I get a 0. Or second time I do get 0. So here I can make a 0 value or 1 character string that is value 0, or a 2 character string that is the value is 2, like 1, 0. And then here, next value here is 0. The lowest 0 character string is 0. The lowest 1 character string is still 0. Lowest 2 character string is 0s. And the lowest 3 character string is 1, 0, 0, which is 2 times 2 is 4. And then here, when I add a 0 to a binary number, I'm pretty sure it multiplies by 2, right? It's like, if it's 1, 1, which is 3, if I do 1, 0, 1, 1, 0, the 2 space becomes a 4 space, the 1 space becomes a 2 space. So that's 6, 4 plus 2. Okay, yeah, okay. So the next one is a 1. So this is still 0, this is still 0. So 0, 1, 2 is still 0. 3 is now, instead of 4, it could be this thing times 2 plus 1, which is 1. And then the next one is going to be 4 times 2 is 8 plus the 1 is 9. Okay. Yeah. I think that works out. So I think I can probably figure out how to do this right. So for every dp, for every I think maybe this is not right. For every index in the range of dp, the length of dp, dp of index plus 1 is equal to minimum of dp of index plus 1 or dp of index times 2 plus this current value. I think I need to do this in reverse order, otherwise the side effects are gonna screw up the thing. And I guess maybe I do, unless I want to do some appending stuff. If I do appending stuff, then I would just iterate through it. Iterate to the size of dp. It would iterate through to the size of dp. Okay, maybe I can say it's like this. I guess this is only going to be bad if Alright, I think maybe that's kind of fine. This is no, it still needs to go backwards. It needs to go backwards. BP starts at 0. If it starts at 0, then what? Then I need to start by appending first. Start by appending to the last, and then iterating over the remaining stuff. Otherwise, there would just be infinities here. Okay, maybe that's fine. So actually, I think maybe the way I can pop or not have that would be for every index in range for the last I'll go backwards, but I also want to keep track of. Okay, I'll say here valid is up to index 0. So the last valid index is index 0, decrementing from there. So if I have index 0, so if I have index 0, and then I look at dp of index 1, which is going to be infinity, I can either keep the infinity, or I can say I can use the first bit here, which would make dp of index, which is index 0, which is 0, 0 times 2 is 0 plus value is 1. So I'd make this thing to 1. And then I would stop there. And now there's 2 valid indices within the dp array. In the next loop, bit is now 0. The bit is character 0, and the value of that bit is integer 0. starting with the last valid index, which is valid index 1. The next one is going to be infinity, or 2 times 1 plus 0, which is 2. So it does 2. And then valid index decrements down to 0. And then it says that I can either keep the 1 there, or I can do 2 times 0 plus the current value 0. So replace it with 0. Yeah. And then I only... Well, why would I increase the valid here? Shit. Valid should not increase here. Valid should increase when I remove something from the end and make the infinity not infinity. So maybe I should have a special case there. If dp of the last thing, which is at valid times 2 plus the value is less than or equal to k, then I need to actually do the next one. dp of the valid is going to be incremented. The valid is going to be incremented. And dp of that is going to be dp of, actually, let's just go ahead and just use the same thing. dp of valid plus 1 is equal to dp of valid times 2 plus value, increment valid at that point. So everything here is valid. Here's valid. Oh, I need to have that same logic in the other cases. I can't actually use, well, yeah, I don't think I can just multiply by 2 and put the value. Or can I? If it's the minimum, then it's always going to be smaller than k. Times 2 plus 1. I think this might be fine. Okay, so do I want to start with valid? So this is going to go 0 to 1 here at this loop. I think I want to start with everything below valid at that point. Valid is going to include the last. I already have special handling for the last. So this is valid minus 1. So this thing is going to do this if statement, puts that 1 there. Valid is currently 1. Valid is currently 1. That's a little redundant, and then it does the same thing again. But it's not redundant if it's an old valid number. Yeah, okay. I think I'm gonna try that. And then I just return the number of valids, I guess. Either the number valid or number valid plus 1, maybe. Okay, well, that's something, I guess. Okay. I'll take it for a first run. It's not particularly fast. Well, I mean, it's not, yeah, it's not fast. I guess if the value itself is something that's super low, then like a bunch of zeros, there's no improving on it. So I can say here that if, and especially since I'm going backwards, if dp at this index plus 1 equals 0, then just break, because everything below that's going to be zeros. From, what was it? I mean, it didn't change me relative to the previous performance. It was like 5 to 8%. But it's an order of magnitude faster. Small gains. Okay. Still need to improve. I wonder. So you're adding a 1. You're adding a 0. If you're adding a 1 to the left side, I guess at the point where if you're adding a 0, then that could change things pretty well. But if you're adding a 1, how often is it that you're actually improving it? Like if you're not actually improving it, then you probably are wanting to break, because at that point there is no improvement to be found. At that point there is no improvement to be found. If you have a 0, then you could possibly improve things. But if you're considering a 1, a 1 is the biggest thing that you can attach. So maybe I can break a little earlier. And say maybe I can do the comparison. New value is dp of index times 2 plus value. If this new value is less than dp of index plus 1, dp of index plus 1 is equal to this new value, else break, because if you can't prove it, then what are you doing? I think this logic is correct. Index, it's not right, index times 2. Okay, not correct, not sound. If the new value is smaller than the yeah, that's just not sound, huh? Output is 3. Hmm. So hmm. New value. The new value is okay. Maybe it's less than or equal to. Actually, maybe I can do the reverse logic. If the new value makes the previous value bigger, then maybe you don't want to do it. Otherwise, you're fine doing it. This doesn't feel like the best way to approach these type of problems. Like using half logic and testing whether or not the half logic works. Okay, well, I mean, it doesn't look like an improvement, but technically I think that's the order of magnitude, 2 times speed faster. Roughly maybe 40% faster. 130 to 1 to 80. Still on the higher end. So you go through all your bits. I guess. Is it possible? So if your new value is going to make your old value bigger, then just don't even bother. Otherwise, change it. Otherwise, change it. I guess maybe you can combine these into one statement. If the dp of this index is 0, or dp of this index times 2 is the value is greater than dp of index plus 1, break. And then this is dp of plus, same mistake, index times 2 plus value, dp of index times 2 plus the value. Calculating this awfully, seems like redundantly calculating this. Value is okay. Maybe I should just have value array is 1 if k equals 1 for k in S. And then I guess I can just use for every value, actually I'll call this bits, for every value in bits. I don't know if that really speeds up all that much. Oh, it's 1 if dot else 0. Yes, semicolon. Semicolon, colon. Yes, marginal. I think maybe at this point I don't know if I need n+1 here. I think maybe I can just have dp be initially 0, and then I can say if this thing times value is less than or equal to k, then I just append dp.append valid, or the last thing, times 2 plus the value. And the valid plus equals 1. And then I iterate over the remaining stuff. Is that right? I could also do this in reverse. I could also... No, I can't do that in reverse. Okay. What is this extra comma doing? Is there a fourth parameter I can have for a range method? For the range function? Okay, my memory is somewhat improved. I think that might be a random fluctuation though. Like this thing seems to be 0 runtime. Oh my god, it's 0 runtime. So I can definitely not be doing this. This is like n squared, I want to say. Okay, so let's rethink about this. If I were to do a one pass on this, so not a for loop with a for loop, but just a for loop. Actually, let me look at a hint. Deleting all other digits. And the string is deleting all the other digits. Interesting. So you either delete this one, delete this one, or delete this one. So if you did a single pass and you considered for each you did a single pass and so if you kept this one, I assume that you're keeping all your zeros. You're keeping your zeros after it. Maybe. A is 5. So what is the value of this one? The value of that one would be, if you kept it, If you kept it, then the value would be 1 if you go left to right. But then if you go right to left, you kept it and all the zeros to the left of it, then the value would be maybe 2 to the 6 or something like that. How do you know? How do you know? So if you kept deleting all the other ones, so you've kept the zeros. Obviously, you keep all the leading zeros because then, like, why wouldn't you? So if you did one pass means, well, it doesn't mean much. Hopefully, it means that you can at each point determine what to do correctly. So you see the 1. What's the harm of adding a 1? Makes the value of this thing becomes 0 times 2 plus 1, which is 1. Or, okay. And then you see another 1. Well, now you can make 1 times 2 plus 1 is 3. You can make something longer that's 3. Or what? Or nothing. And then you see another 1. You can make something that's longer that adds in that 1. Or you can, the 1, yeah, the 1 always makes something longer, increase the value by 1. So is the 1 only gonna help you if you want to append it? You never really want to take a 1 that you're not appending, right? Because otherwise you'd be replacing something that is like, if you have, let's say your string is initially 6 and your 7th character is a 1. Well, sure, that's fine. Whatever the 6th character is, you append a 1 and make it bigger. But if you had some previous value, let's say that's a minimum value, that's 5. The minimum value is 5, appending a 1 is always going to be bigger than whatever you had before. Yeah, so you only append if this is valid, and then if the bit is a 1, the value is 1, then just continue. Yeah, I don't know if that really helps speed. I don't know if that really works even. Okay. Valid plus equals 1. So the answer here was what? The answer here was 29. My answer was 29, but the expected was 31. I think I see it. It's because previously you had a 1 somewhere, and then you changed to something smaller to become a 0, and now you want to go back up to something that's 1. Fuck. Yeah, you can make something small, and then you need to make it something big again. Hmm. What if you went through, so you start with all how many number of zeros there are. So you just remove all your ones. And now you're inserting, you remove all your ones, now you're inserting ones back into it. So what's the optimal places for you to insert the ones back into? The optimal places that you insert the ones back into would be the rightmost one. Is that always right though? If you insert the rightmost one, then you're giving up on, you're increasing the value by whatever that is. And you're giving up on a 0. But it could be fine. No, you're not necessarily giving up on a 0. You're just increasing the value thing by this value. Do you always want that? Maybe not. So fruit counter. So initially have 18 zeros and 15 ones. I go to the rightmost one. I could make this a one that has a place value of 2. So now my string is 19 long, 18 zeros and a 1. And then I go to the next one. And I could make this into, what would the benefit here be? I could make this one into something as part of the 00, as part of the ending of 10010. And that would make it into a 20 string, 18 to 19 to 20, where the 20 string has, something that is 2 plus 4, 8, 16. 2 plus 16 is 18, so the value of the 26 is 18. But what if I didn't do that? Then I would have something where if I didn't have that, then in theory I could also say remove the 1 and have this be 16, no, 0, 0, 0, 1, so that'd be 8. So 19 length and 8 value, 19 length and 2 value, or 19 length or 20 length and 18 value. So for each additional one, if I insert it back in, then if I insert it back in, then what? Oh, Oh. So close to just quitting on this one. But I find I've been quitting more recently, like just giving up before. I don't know. Either I'm getting worse, or the problems are getting harder, or some combination of that. Or I guess it could be I'm going slightly better, but the problems are getting a lot worse, so therefore something. I'm guessing the problems are generally the same, but I'm just getting worse. Getting worse about just grinding for the solution, the best solution. Maybe I'm too distracted. Zero, 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 zero. One. If I insert the one. Alright. Oops. I might as well look at the last hint. There is one. If you were to move a digit, which one would you remove to reduce the value of the string? So I mean, I guess you remove the leftmost one. So I mean, you start with the whole thing, and you just keep on removing the leftmost one until the thing is smaller. Is that simple? I guess the leftmost one is going to be the biggest one. Is that simple, huh? The size of this is so big. So if you remove it, then if you remove it, you always want to remove the leftmost one. But what do you start with? Do you start with the whole thing? If you calculate that, that's just too big. 2 to the 10th, 2 to the 100,000, or 2 to the 1,000 is too big. So I could do you always remove the leftmost one? Start with the whole thing, you remove this one, look at what's remaining. And then if that doesn't work, then you keep on removing this one, this one. So you remove this one. That doesn't work, you remove this one. That doesn't work, you remove this one. Remove this one. 0, 0, 0. Then you remove this one. 0, 0, 0, 0, 0, 0, 1. How do you know what the value that remains is? How do you know what the value that remains is? I guess you in theory that means that you should be able to work right to left. Pick up everything. Yeah, I guess you just should work right to left. Is there a reason why you can't be greedy with picking up the rightmost one as long as it keeps the number smaller. If you were to be greedy and pick the rightmost one, shores 2, and then all these things are zeros. Okay, well let's go ahead and just try it. So I can say my bits are that, and then my overall value starts with 0, and then for every value in bits backwards, answer 0. Answer 0. If I keep on adding to the right, and going backwards through the bits, if my overall value if the if overall if the overall, so I always had ones, I always had zeros. If the value equals 0, answers can be appended by 1. Every zero I encounter, I add it. And then I can say and continue because the overall is just not going to be different. Otherwise, this is a 1 bit. If the overall value plus plus 1 in this spot, so 2 to the power of 1 in this spot would be, let's say the answer currently has 0 bits, so that'd be 2 to the 0, which is 2 to the answer is less than k, less than or equal to k. Then overall equal will increase by 2 to the answer. So 1 in the 0 spot, and that's 1's value. It's 1 in the 2 spot. Answer is where 1 lane 2 versus 2. And then answer plus equals 1. I think that's fine. And then return the answer. Huh. Okay. I think maybe this is probably slowing it down. For every bit in S backwards, where if the bit is 0, then keep on going. Actually, maybe probably if I don't want to create a new string, I can just say for every index in the range of S of n minus 1 to -1, and then bit would just be S at index. All right. S at index is 0. Answer increases if I add a 1 here. I think maybe if I had two separate things here. All right. Where was that? So when I have a 1 bit that makes it too big, then I should be able to stop the loop. But the issue with stopping the loop then would be, whoa, what's going on? The issue with stopping the loop would be, yeah, what's going on with this screen? Alright, the issue with stopping the loop is I still need to get all the zeros. So maybe I should be doing answer. Maybe I should just be doing answer equals the number of zeros to start with. Answer is equal to number of zeros to start with. Would I ever not use the zeros? Yeah, I think I'm using all the zeros all the time. And I'm just figuring out which ones to add into it. So the overall is going to be starting at 0 is the value. Yeah, so if I just do a count, counter of S. So let's say my answer is initially the number of zeros, count of the zeros, and then my overall is going to increase if the value that I'm adding, if the bit is 1 and it doesn't cause the current value to be greater than k, then I'm going to do that, else I'm going to break. Actually, if s index equals 1, then check this. Else break if it's 1 and you don't have, and it's too big. Okay. Tell you what breaks right now is this whole thing. Okay. If s index overall value is 0, you increase, you see a 1, the 1 makes the overall value increase, assuming still less than k. If it can't, then the answer shouldn't increase at all. My count is 4, it's 5, 5, 6, 9, 10. That's a pretty big gap, 26, 31. Okay, so what did I do that was that much different? So the number of zeros is the starting point. Overall starts out with 0. You go through your indices backwards. If the value plus 2 times the answer, 2 to the power of the answer. Oh, it's starting too big. It's starting too big. The answer is the current value of things. I see, I see. So it should be 2 times n minus the index. I could just say, I can just do this normally. Say index is in the range of n, and I index into n minus 1 minus index. So going backwards and then going with this index. Overall is 2 plus, overall plus equals 2 to the power of index. Oh my god. Well, that required no dynamic programming. That just required me to go through logic that I didn't think was correct. And also use hints, which is also not great. Summary, this is kind of a need to detect the basic logic, basic math logic, whereby the best solution, which can be found through a greedy approach of taking all zeros and kind of inserting or kind of reinserting inserting ones rightmost to left as long as the value of as long as the overall value remains less than k, remains less than or equal to k. So, you know, have a separate count. So overall, you know, count zeros and ones. Answer has a baseline of count of zeros. Iterate over bits backwards and see while keeping track of current overall value and see if any ones added at that place value, which is generally going to be 2 to the power of index. See if any ones added at that place value keeps the overall lower less than or equal to k. If so, insert that one, change overall, increment overall, and answer. Alright, that's time complexity is going to be O of n, where n is the length of the string. Oh, also you can break early if any one causes overall value to be above k, as later ones will always have even higher place value. And here, yeah, it's just O of n for the length of the string. You're just doing it all once. It's basically this O1. All right.